Differentiation, Chapters 10.6. Finding the derivative of a cubic function gives quadratic function. Finding the derivative of quadratic function gives you a linear function. Finding the derivative of linear function gives you a constant. And finding the derivative of a constant gives you a zero. This is known as the derivative dam. Introduction. The term differential calculus was introduced in its Latin form, calculus differentiale, by Gottfried Leibniz. Newton referred to calculus as the method of fluxions, from Latin meaning to flow. Differential calculus is the study of derivative and its applications. The derivative is the rate of change. It is the slope of a tangent line. It is the limit of a difference quotient. How might we use the slope of the secant line in Figure 1a and limits to find the slope of the tangent line in Figure 1b? So as you see here in Figure A, you have a secant line. It's a line that passes through 2 points on the curve. So when point Q move towards point P, and at a certain time these 2 points will overlap. At that point, secant line turns to become tangent line. And in order to describe this, we find the limit of x as it goes closer to a, and finding the limit of that quantity, which is known as the difference quotient, gives you the derivative of the function. So this is what you see here. You have like four different figures where you see tangent line, or actually secant line is turning into become tangent line. And to describe this phenomena, we describe it using f prime of a equals to limit as x goes to a of f of x minus f of a over x minus a. So again, in this, the secant line turns into become a tangent line, and limit of the tangent line is called derivative. So when finding derivative at point A, we call that f prime of a equals to limit as limit of x minus f of x minus f of a over x minus a as x goes to a. Limit as x goes to as h goes to 0 of f of a plus h minus f of a over h. The derivative of a function f at x goes to a is the limit of the difference quotients if it exists. F prime of a equals to limit as h goes to 0 of f of a plus h minus f of a over h. When the limit exists, we say that f is differentiable at x equal to a. An equivalent definition of the derivative is f prime of a equals to f of x minus f of a over x minus a as x goes to a.